Hi there. I am Arlissa with 8-Minute Maths, and we are here today to do a video on solving systems of equations with three variables. We've got a few examples we will walk through, showing how to solve systems of equations when you have three variables. Okay, let's get started. For example number 1, we have three equations. We have 3x minus 5y plus 4z equals 5. We have 5x plus 2y plus z equals 0. And we have 2x plus 3y minus 2z equals 3. I'm going to call these equations 1, 2, and 3 to start off with. It'll mean something to you in a minute when I start to combine equations, so you'll know which ones we're talking about, okay? So when you're solving equations with three variables, you're going to combine the use of elimination and substitution. The key is that you need to get these three variables initially down to two variables and then down to one variable so you can solve for that one. And then you substitute back into previous equations in order to get to the to all three variables with a solution. So I've decided to start by multiplying equation number 3 by 2. Why am I doing that? Multiplying equation number 3 by 2 because I'm going to combine it with equation 1. So let's start there. I'm going to multiply equation 3 by a positive 2. There we go. Multiply 3 times 2. So now we're taking this equation here, 2x plus 3y minus 2z equals 3, and we're multiplying the entire equation times 2. So we have 4x plus 6y minus 4z equals 6. This is still equation 3. We've just multiplied it by 2. Now we can combine that. I'm going to bring equation 1 down so we can combine these two together. 3x minus 5y plus 4z equals 5. This is equation number 1. I just brought it down. So now we have these two equations we can work with. We're going to add these two equations because we have negative 4z, positive 4z. These can cancel out. So right off, first step, we can cross those off. We're adding these, so we now have 7x plus, I'm going to put invisible 1 here, plus 1y equals 11. This now I'm going to call equation number 4 because it's the result of us combining 3 and 1 together. That's equation 4. Now we need to do some more equations where we can combine them and have a x and y left together. So let's look at equation 2. If we multiply equation 2 by negative 4, then we're also going to be in a place where we've got positive 4, negative 4. Okay, so now we're going to multiply equation 2 by, what did I say, negative 4? We're going to multiply equation 2 by negative 4. So let's bring equation 2 down. 5x plus 2y plus z equals 0. We're multiplying the entire equation by negative 4. Multiply by negative 4. So now we have negative 20x minus 8y minus 4z equals 0. This is still equation, this was equation 2. This is still equation 2. It's just been multiplied by negative 4. We're going to combine this with equation 1. I'm going to bring equation 1 down. 3x minus 5y plus 4z equals 5. You may be questioning, why are we doing this? Well, the key again is we have an equation left that's x and y, but we need to now eliminate the z's. So we can cross off those two z's. We are adding these equations again. So we've got negative 17x minus 13y equals 5. This we are calling now equation 5. We've got some new equations here. So let's look at, we're going to bring equation 4 down. Let's put this down here together. 7x plus y equals 11. And equation 5 we'll put here together. Negative 17x minus 13y equals 5. We have these two. So now we need to see, what do we need to do to one of these equations to get rid of one of the variables? This is usually how it looks when you are solving a system of equations with just two equations and two variables. Now you need to figure out, how do we get back into one variable? Well, two things can happen. We can either solve for y and then substitute that value into here and solve, or we can multiply one of these or the other one by a number and get something that can be eliminated. I've decided, I think it would be best to multiply equation 4 by 13. Multiply equation 4 by 13. So we take 13, we multiply it by 7x plus y equals 11. 2. Erase that. Okay. Multiply by 13. So now we have 91x plus 13y equals 143. And we have negative 17x minus 13y equals 5. Taking these two equations, we add them together. We see that the positive 13y, negative 13y cancel each other out. 91 and a negative 17 gives us 74x equals 148. We solve for the x here. We have x equals 2. Okay, we finally have one variable after a lot of work. We have one variable that we can now work with. We've determined that x equals 2. I'm putting this at the top of the page so we can know where we're going from here. From here, though, let's substitute this into equation 4. We have equation 4 there? Yes, it's right here. Let's substitute x equals 2 into equation 4. Well, our equation 4 is 7x plus y equals 11. We're putting 2 in place of our x. Solving for y, 14 plus y equals 11. We're subtracting 14 from both sides. So y equals negative 3. Now we've got two variables. We've got x equals 2. We've got y equals negative 3. And I think we can now substitute this. We could pick either one of these equations to substitute the x and the y back into. Let's pick the easiest one because we're trying to find z equals. This is the only one that has z by itself with no coefficient, so it will be a good one to use. So we're going to substitute x equals 2 and y equals negative 3 into equation 2. Okay, so we have 5x plus 2y plus z equals 0. 5 times the 2, we found that value, plus 2 times negative 3 plus z equals 0. 10 minus 6 plus z equals 0. Now we have 4 plus z equals 0. Let's subtract 4 from both sides. And z equals negative 4. So our solution to this system of equations is 2, -3, -4. This is our x value, our y value, and our z value. To ensure that this is correct, you can take all three of these numbers or the solutions that you found, substitute them back into the original three equations, and when they're all proved to be true, you'll know that what you did was correct. Okay, that was a pretty long example. You see that it's very methodical, very logical, that you have to make through all the walk through the steps. I would suggest that you not try to do a lot of this stuff in your head, because when you try to do a lot of these things in your head, you have the opportunity to make mistakes. All right, let's move on to example 2. Example 2 is 5x plus 3y equals -6. Come on and focus. There we go. And we've got 2y plus 3z equals -1, and 7x plus z equals 1. When you have the all of these and you're trying to figure out which is the correct answer or which is the correct equation to work with. When you have, like for equation 1, I'm going to give these the numbers again like I did the other ones, equation 1, equation 2, and equation 3. When you have all three of these together, you're seeing that, like with the first one, x and y is here, but there's no z. So basically there is 0 z. And the second equation, you have y and z, so there's a 0x. And 7x plus z means there's a 0y. You can't, at this point, eliminate a variable and end up with one variable left that you can work with. So we've got to do a little bit of manipulation. Let's start by multiplying the third equation by -3. Why are we going to do that? Well, if we multiply the third equation by -3, we can get rid of the z's. And we're just left with x and y. Then we can work with equation 1 with the x and y left from 2 and 3. We can work that with equation 1 and do some solutions. So I'm going to say, let's multiply equation 3 by -3. So we have 7x plus z equals 1. We're multiplying this entire equation by -3. So we have -21x minus 3z equals -3. This is still our equation 3, just has been multiplied. Now let's combine that with equation number 2. Why equation number 2? Because we want to have the x and y left. I'm putting this 2y here in the middle. I probably should have put like an x with a space for the y, but let's just go with it now. Well, x and y cannot combine together. So what you're left with is -21x plus 2y, because these two are not like terms. The -3z and the +3z cancel each other out, and you have -4. I was adding these two equations together. So we have -21x plus 2y equals -4. This now we're going to call our equation 4. We created a new equation based on what we're working with. But this, because it has x and y, it can be combined with equation 1 because it also has x and y. So I'm going to bring equation 1 down. 5x plus 3y equals -6. We can't do anything with these just yet. We need to either get this into a place where we can substitute or we need to eliminate. So what we're going to do here is it would probably be best if we got the 2y and the 3y into a positive and a -6y. So I'm going to suggest that we multiply equation 4 by -3. Let's do that first. negative 21x plus 2y equals negative 4. We're multiplying all of equation 4 by negative 3. So we have 63x minus 6y equals positive 12. This is still equation 4. It's just been multiplied. Now let's multiply equation 1 by 2. Multiplying equation 1 by 2. So we've got 2 times 5x plus 3y equals negative 6. This gives us 10x plus 6y equals negative 12. This is still equation 1. Now let's put 1 and 4 together. Draw a line here. Combine 1 and 4. Okay, so we've got 10x plus 6y equals negative 12. And equation 4 is 63x minus 6y equals positive 12. We're combining these by adding. Well, the plus 6y minus 6y, these now cancel each other out. And we have 73x equals negative 12 plus 12 is 0. So x equals 0. Now we have one value that we can work with. X equals 0. Let's substitute our x equals 0 back into equation 1 or 4. I like equation 1 because that way we haven't made any mistakes there. Well, it depends. Let's substitute into equation 1. I'm going to take this. I'm going to work back up here, going back so I have some more room. Substitute x equals 0 into, what did I do? Into equation, let's go with equation 3. I like that idea. Equation 3 is 7x plus z equals 1. Why is that a good one to choose? Well, it's a good one to choose because now you're going to be left with z equals. Z doesn't have a coefficient. When you put 0 in for the x, you're going to be left with just z. So z equals 1. Now we've got two variables or two solution points that we have for these three equations. Now that we have x and z, we can choose either equation 2 or we can choose equation 1. 1 to 1 or 2 because equations 1 and 2 have a x. One has an x. You can solve for y. This one has a z. We know the value of z. You can also solve for y. That's what we need next is we need to solve for y. So I'm going to go with equation 2. Substitute z equals 1 into equation 2. And then we can solve for y. So equation 2, 2y plus 3z equals negative 1. Well, we're putting z equals 1 in. So 2y plus 3 times 1 equals negative 1. 2y plus 3 equals negative 1. Subtract 3 from both sides. And we have 2y equals negative 4. So y equals negative 2. So based on our solutions now, we have x, we have y, and we have z. I'm going back to the top of the page so that way we can see that we have found our solution. Solution is 0 for x, negative 2 for y, and 1 for z. This is our x, our y, and our z. We can put these back into the original equations to see if these are true. Let's put these in. 5 times 0, 0, plus 3 times negative 2, which is negative 6, and negative 6 does equal negative 6. This one checks out. 2y, which is 2 times negative 2, so that's negative 4, plus 3 times 0 is z? No, z is 1, sorry. Plus 3 times 1, so negative 4 plus 3 does equal negative 1. I was getting myself confused. And then 7x, x is 0, so 0 plus 1 does equal 1. All three of these check out, and they are all three true. So we see that this solution is a good one for this system of equations. All right. Whew. So I have one more example, but it's a long one because it includes fractions. I'm not sure if we want to do one that includes fractions, but let's plug ahead, because I found that if we do too many simple, not that these two have been simple, but if we do too many simple examples, then when you get to class and the problems are harder, then you said, all I ever saw was simple examples. So let's go with this. X plus 5 over 2y plus z equals negative 2. 2x plus 2y plus 1/2 z equals negative 4. And 1/3 x minus y minus z equals 1. I'm going to call these again equations 1, 2, and 3. Now, because many people are not a big fan of fractions, we can take these and turn them all into whole number problems. We do this top one by multiplying by 2. Why by 2? Because we want to get rid of this denominator of 2. So this equation becomes 2x plus 5y plus 2z equals negative 4. Then the second equation, we're also going to multiply by 2 because we want to get rid of this denominator. So we now have 4x plus 4y plus z equals negative 8. Last but not least, we're going to multiply this equation by 3. So that way we can get rid of this fraction here. So we're left with x minus 3y minus 3z equals 3. These are our new equations 1, 2, and 3. New equations now. We've just gotten rid of the fractions. So what can we do now to get ourselves ready to eliminate? Well, looking at these equations, we can multiply equation number 2 by 3, and that will cancel out these z's. I think I'm going to do that. Okay. Multiply equation 2 by a positive 3. Let's do that. 3 times 4x plus 4y plus z equals negative 8. This gives us 12x plus 12y plus 3z equals negative 24. This is still our equation number 2. It's just been modified. We're going to combine this with equation 3. Let me see, combine with 3. Okay, so we have x minus 3y minus 3z equals 3. Why are we combining these two, or why are we adding these two together? It's because we now have positive 3z, negative 3z. They cancel each other out. And we're left with 13x plus 9y equals negative 21. This now we're going to call our equation number 4. Equation number 4. What else can we do to get an x and y together? Well, we can work with 1 and 2. We need to get equation number 2 with a negative 2z. So let's multiply equation 2 by negative 2. So we've got negative 2 times 4x plus 4y plus z equals negative 8. This gives us negative 8x minus 8y minus 2z equals a positive 16. This is still equation 2, just been multiplied. We're going to combine it with 1. Combine with equation 1, where we have 2x plus 5y plus 2z equals negative 4. Combining these by adding. This is our equation 1. Negative 8x plus 2x is negative 6x. Negative 8y and 5y is negative 3y. The negative 2z, positive 2z cancels, equals positive 12. Wait a minute. Yeah, okay. Trying to make sure I didn't make an error here. We multiplied equation 2 times negative 2. That gave us a positive 16. Very good. And then we combine with equation 1, 2x, 5y, 2z equals negative 4. Combine these together, negative 6x minus 3y equals positive 12. Okay. Now we've got an x and a y. For this we're calling this equation number 5. Now 4 and 5 both are x and y, so let's work x and y together. Equation 4. Put equation 4 with equation 5. We've got 13x plus 9y equals negative 21. And we've got negative 6x minus 3y equals 12. Well, now that we're combining these together, let's see what we need to do. Can we multiply equation number 5 by 3 and then combine these? I think we can. So multiply equation 5 by a positive 3. So we've got 3 times negative 6x minus 3y equals 12. So negative 18x minus 9y equals 36. This is still equation 5. We're going to combine it with equation 4. This is our equation 4. We're adding these together. So we have negative 5x. These two cancel. Equals, what's this, 15? 36 minus 21 is 15. Divide both sides by negative 5. Divide by negative 5. And you have x equals negative 3. X equals negative 3. So we have one solution that we've come up with. Let's substitute this x equals negative 3 back into equation 4 or 5. I think we can do this. I'm going to jump us back up to, let's see where we are. Equation 4 is, we're putting in an x. That works for me. Substitute x equals negative 3 into equation 4. Equation 4 is 13x plus 9y equals negative 21. So we've got 13 times negative 3 plus 9y equals negative 21. So this is negative 39 plus 9y equals negative 21. I want us a little more room. Let me create some more space for myself. We're adding 39 to both sides. Add 39 to both sides. We have 9y equals positive 18. Divide both sides by 9 and y equals 2. Y equals 2 there. So now we have x equals negative 3. and y equals 2, we can look back at our original equations, which I'm putting these here so we can see what they originally were, equations 1, 2, and 3. We have x and y. We're trying to find z. One of the best ones probably would be equation 2 because z doesn't have a coefficient here. So let's substitute those into equation 2. Equation 2 is 4x plus 4y plus z equals -8. So we've got 4 times -3 plus 4 times 2 plus z equals -8. -12 plus 8 plus z equals -8. These two together, -4 plus z equals -8. Add 4 to both sides. We have z equals -4. Z equals -4. So our solution to these three equations, I want to keep this together. Our solution to these three equations, we have x, y, and z. I'm going to write it over here next to the equations. We have x equals -3, y equals 2, and z equals -4. This is our x, this is our y, this is our z. The solution to these three equations, x, y, and z. Remember, you've not found a solution until you've got a value for all three variables in a system of equations that has three variables. If it has three variables, that's when you've got your solution there. So let's talk. At the end of this, our next video is going to include, I think we're going to move on to exponents. We're going to get very deep into exponents. That will be our next video. So definitely look for that in our next video. Okay. I want you to know that we have all of these things we are talking about. They're coming from this survival kit. They're coming from the survival kit that I've created. It includes, oh my goodness, so much stuff. The survival kit includes so many things. I want to go back to the page where you can see exactly what's in the survival kit. Survival kit, this is our table of contents for the survival kit. It includes how do you use the kit, how to get off to a good start, reviewing the prerequisites, including all the things that are kind of the teacher expects you to know before the class, the meat of the content, polynomials, factoring, functions, systems, and then how do we finish strong. Up here in the Get Off to a Good Start, we have the basic skills refresher videos. These videos include exponents and equations, basic equations, inequalities, working with rational numbers, working with integers, just really a good refresher on all the basics, the basic rules for exponents and those things. This all comes as videos, so you can watch these videos. Page 10 gives you access to all those videos. And then you go on down here, rational numbers, exponents, with a workbook, polynomials, how to get deep into polynomials, factoring, function systems. All this stuff is available in the survival kit, and the survival kit is for this month on sale for $50. You can go to bit.ly/algebra-survival-kit and see exactly what's in the survival kit, which I just showed you the table of contents, but you also get a few sample pages there. You can see the items listed. And you should go forward and pick up you one of these copies because it's a immediately downloadable PDF. Everything you need is accessible there, and you get it immediately after your payment. You don't have to wait for anything to come in the mail. You can get immediate access to the hundreds of practice problems with solutions that are there, like workbook and quizzes. Okay, so I think I will see you in the next video. I look forward to seeing you in the next video. You can go to 8minutemaths.com, check out our site, like our page. We're also on YouTube at Arlissa Pinkleton with 8-Minute Maths. You can find us on LinkedIn at Arlissa Pinkleton, 8-Minute Maths. But yeah, communicate with us. On Facebook, there's a page called 8-Minute Maths, Help for Women Returning to College. It's really a support group that is available for those who are returning to college or thinking about returning to college. And you can get a lot of resources there, interaction with a community as well as with me. And that'll help you definitely be prepared and be more secure and ready for your math class. Because our objective is that you would pass your math class with no issues. All right, so I look forward to seeing you in the next video. Bye-bye. If this video has been helpful to you, then subscribe to the channel so you can be notified when new videos are posted. Also, visit us at 8minutemaths.com where you can see our content and resources and courses, things that are available to you there. Lastly, follow us on Facebook at 8minutemathshelp.com. We look forward to seeing you there.